So welcome back to the second half of the example of Chapter 8 from the Yaki text. So we were up to the post hoc test, and the particular post hoc test we selected was the Tukey HSD. HSD stands for highly significant difference, and this first table makes multiple comparisons between the groups. So let's take a look at what this is actually telling us. So I want to point out the fact that we've got this column here that says strategy, and then we've got another column here that says strategy. So let's take a look at what they're trying to get at here. So what we're doing is we're comparing strategy A versus strategy B, and this tells us the difference between the means, and then this is the significance of that difference. And again, using our rule of thumb of 0.05, we can see that that's greater than 0.05. So that tells us that while there's some difference somewhere that exists between these three groups, there's not a significant difference between Group A and Group B, or Strategy A and Strategy B. However, if we looked at the next row, we can see now we're comparing strategy A versus strategy C, and recognize the fact that our p-value now is less than 0.001. So that tells us that there is a significant difference between strategy A and strategy B. Now I want to show you something over here that, again, this confidence intervals can also tell us something about this. Now you'll notice that the lower bound of this confidence interval for the comparison between strategy A and B is negative, and then this one is positive. So that includes 0. And if your confidence interval includes 0, that tells you that there's not a significant difference between those two groups. However, when we look at the relationship between strategy A and strategy C, that this confidence interval does not include 0. So that tells us that this mean difference here, this 4.2, is not going to, the confidence interval is not going to include 0. So that tells us that there's a significant difference between strategy A and strategy C. So moving on this and analyzing this further, if I look at the second case where I'm looking at strategy B versus A, no big surprise, that's 0.138. But if I look at the relationship between strategy B and strategy C, I can see there is a significant difference between those two. And then the final row across here is comparing strategy C to strategies A and B. We can see that there's a significant difference between those. So all of that information just sort of leads us to the fact that we've got three different things going on. I can see that strategy A is not significantly different from strategy B. So that very first line tells me that. Strategy A is statistically significantly different from strategy C. That second line tells me that. And then finally, strategy B is statistically significantly different from strategy C. So I can see that here where I compare B to C, or I can see that here where I compare strategy C to strategy B. Okay, so that's painting the picture of where we are with this relationship. Now notice that this tells me right here that the mean difference is significant at the 0.05 level. So that's the level that we recall when we set up our post hoc test. So the star here means that 4.2 is statistically significant, and then this one, this 5.5, is statistically significant. So there's a lot of different ways of looking at this, and all of them sort of point to the same thing. Now, as part of the output from your post hoc test, you also get this other table that's set up in a little bit different way that's called homogeneous subsets. And so this is kind of a down and dirty look at it. This tells me strategy C, here's my N for that, there were 10 individuals, and the mean was 4.7. Strategy A had a mean of 8.9, strategy B had a mean of 10.2. And so notice that C is in a different column than A and B are. Now if two independent variables, the categories, are in the same column, that means they're not significantly different from one another. However, if they're in a different column, then there is a difference between the groups. So this tells me that strategy C is significantly different from strategy A and from strategy B. However, there's not a difference between A and B. And so this is a different way of looking at this. Now, one other thing I want you to note is down here it says this uses the harmonic mean sample size of 10. In this particular case, all three of our groups were the same size. There was 10. However, if you get groups that are radically different in terms of their size, this table here may give you a different result than the first table that we looked at. So that's something important to keep in mind. So we can have the same conclusions from this homogeneous subsets table as we had before, that A is not different than B, A is different from C, and that B is different from C. So that's our overall look at that. So the last thing we're going to look at, or the second to last thing, is how to calculate effect size. So recall from our previous videos we talked about eta square, and so recall that eta square is sum of squares between divided by sum of squares total. So here's the sum of squares between, here's sum of squares total. So eta squared tells us something about the relationship between our categorical variable and our outcome dependent variable. So in this particular case, even though it's not provided in this ANOVA table, you would need to go ahead and calculate eta squared by dividing 165 by 223, and that's equal to 0.738. Now eta squared is always going to be less than 1 because your between group sum of squares is added to the within group sum of squares to give you the total. So between group sum of squares always has to be smaller than the total, so therefore eta squared is always going to be less than 1. Now we can interpret eta squared as the percent of variance in the dependent variable that's explained by your categorical variable. In this case, we can say that 73.8% of the variance in word recall is explained by the learning strategy. So this is an important piece that you're going to want to include in any write-up that you have of using your APA format or of your experiment. So you need to include the results of the null hypothesis significance test. In other words, was it statistically significant differences between the groups? And then you're also going to need to include the effect size, which is the eta squared. So let's finish up by taking a look at the APA write-up that Yaki used in the text for this particular example. So he says that the write-up should say the number of words recalled varied by the learning strategy used. So here's where we report the F statistic. Notice that F is italicized, and then we have the 2 degrees of freedom. So the first one is from the numerator, and the second one is from the denominator. And so we include both of those in parentheses, and then we give the value for it. Then we say P, and we would ordinarily report the exact P value, but in this case, since SPSS reported as 0.000, we by convention report that as P is less than 0.001. Then I provide the eta squared. Okay, so here's our effect size. So the F, the p-value, and the eta squared tell me about these results of the initial analysis. Then he goes on to say that Tukey's HSD post hoc procedure indicated that those who use strategy A, and then he provides the mean and standard deviation for strategy A and strategy B, and it says that they recalled significantly more words than those who use strategy C, again reporting the means. So somehow in the text you want to report the results of the analyses that you did as well as the means, because we're not providing a table here, but somebody at some point in time might want to go back and use this information. So we want to be sure that we include both the descriptive statistics as well as the results of the inferential statistical analysis. Then he follows up by saying there was not a significant difference in the number of words recalled between strategies A and B. So this gives us kind of the whole picture of what was going on using the APA formatting. All right, so that concludes our example from Chapter 8, the between subjects ANOVA, you will need to then take the data set that I've provided for you and do a similar type of analysis and do some other comparisons that are outlined in the actual assignment.